If I minimize the point cloud for a moment, I'll open up the floating ice tree. And what I want to actually do here is dealing with the particles node. The problem with particles is that although they respond to their size, their forces, they don't respond to one another. In other words, they don't understand the dimensions of another particle. They will just interpenetrate. So you can solve this by turning the particles into rigid bodies. Now, XSI already has a rigid body simulation engine, and if you switch over to the Simulate menu, we can create our rigid bodies using the PhysX simulation environment or the old ODE environment. In this case, the rigid body environment for the particle system uses the same PhysX engine, and as such there's a limit on the number of particles that you can treat as rigid bodies. I believe the number is somewhere around 30 or 40,000. So a Simulate rigid bodies works exactly the same way a Simulate particles does, except for the fact that the particles are treated as though they understand each other's whereabouts. So they will maintain separation. So if we look under our tools and we look under the simulation category, we'll find a Simulate rigid bodies node. And there are a number of inputs the Simulate rigid bodies node has that the Simulate particles doesn't. You'll notice there are things like geometry for obstacles, elasticity, and static friction. And this doesn't mean that you can't treat rigid bodies the same way you do particles by using things like the slide on surface compound. You can still use objects and their surfaces as collisions. It's just giving you ways to speed up this interaction. So you can use more genetic convex hull shape collision detection for the geometry that's plugged in through here. And of course specify the elasticity and friction on a per particle basis. In this case, the elasticity is designed for the object in question acting as the obstacle. So for the object's own elasticity and friction, we would need to set that in the ice tree using a set data node. In this case, I'm just going to take the Simulate particles, and if I just move back to frame 1, I'll remove the Simulate particles node and replace with the Simulate rigid bodies. Right away, if I just delete the Simulate particles compound now, or the node, you'll notice a big difference. So the particles now don't get in one another's way. They maintain a nice separation from one another, and now when they get to the end of the leaf, we have a sort of a different issue. So again, you can see how it's kind of neat. You can see that this one here clearly got stuck, so we're just going to need to tune the effect so it will fall off. So I'm also going to work with the slide on surface a little bit more. I'm going to keep the, let's see, this actually looks like it's working pretty well. If I want larger drips to fall off, I can also increase the size of the neighboring particles. I could say a size of 8 particles. A number of 8 particles need to be around a particle for it to drip. So in this case here, you get the drip like so. Again, some of these particles don't like to fall off, so we can again just slightly increase these values. 0.8 times the scale of 0.12 would give us a value of, say, 0.96. So we could say 0.97. Just slightly larger. So you should never have a case where objects are sort of getting left behind. If we are having problems with the particles clumping up a little bit too much here, we can again just reduce the rate to 3 particles per second. So it gives us a lot more time for particles to clump together.